multiplying and dividing integers, and this will be a lot easier if you memorize your times table, but if not, you still want to understand like the notation, the way things are written. So first we want to say like what multiplication is. So here's a problem that you probably can do even if you don't remember the definition. Okay, you buy 3 tickets for $5 each. How much did you spend? So a lot of times you already know that that is $15. But what you're actually doing is you're like adding, right? So if we had a number line right here, 0, we're moving 5, we're doing another 5, and then we're doing another 5, and then we get to 15, right? So it's actually, multiplication is actually repeated addition. It's like a shortcut. So the very first people that ever invented math long ago didn't invent multiplication to annoy you. They did it to save some time because they didn't want to add, 10 1,000 times, right? If they had 10 sheep for every, I don't know, Roman, right? They didn't want to be able to add that. They wanted to multiply it. Okay, so if you want to put right here like multiplication is a faster way to add, right? Okay, so our notation, a lot of times you'll see like 3 times 5, right? We'll have that little X there, but what we want to get used to is using the little dot or using parentheses. So you could have 3 and then the 5 is in parentheses, or maybe the 3 is in parentheses, or maybe they're both in parentheses, right? These are all the same thing. But we want to start, we don't want to use the X really anymore because X's you see a lot in algebra. So we sort of want to stop using the X for multiplying. Okay, so when we're looking, right, at these examples, they're all very, very similar. So when we think, right, if we have 3 times 5, we already did that, right, and we get 15. Now 3 times negative 5 is the same thing, but we're starting and we're going in the opposite direction. We're going negative 5, negative 5, negative 5, right? So negative 5, negative 10, negative 15. So our answer is negative 15. If we're doing negative 3 times 5, again, we're going in the negative direction. So negative 15. And then the tricky thing happens when they're both negative. So normally when we're going negative, we go to the left. But since it's a negative 5, we have to flip this way. So we're actually going in the positive direction. So 0, 5, 10, 15. So this one's actually positive 15. You want to be able to do this without your calculator, but obviously you can check with your calculator. Just make sure you don't confuse the minus sign for the negative sign, right? So if we're looking at this like T Inspire, down here is the negative, but this is the minus. So make sure not to mix them up. Okay, so this is the best trick, right? Knowing if it's going to be positive or negative. This comes up all the time. So when we're multiplying, if the signs are the same, the product is positive. And if the signs are different, the product is negative. And just a reminder, product means you're multiplying. Right? If you hear the word sum, that's like adding. So don't get confused if you see product, you should know that you're multiplying. So yeah, pretty much if they're the same, it's positive. If it's different, it's negative. So some examples down here. We have, what I like to do is do the numbers first and then figure out the sign. So 2 times 4 is 8, and then a negative and a negative makes it a positive, so it's just positive 8. So with your tables, I want you to try and do these 4 and then check and see if you got them. Alright, so 4 times 3 we know is 12. They have a different sign, right? One is negative, one is positive, so we know that that's negative, so it's negative 12. 3 times 6, is 18. Negative 4 times 0. So we know the number is 0 because anything times 0 is 0. And you might think, oh, well, one of them is negative. But you can't really have, a 0 is just 0. So it wouldn't really be negative 0, even though 1 is negative and 1 is, 0 is neither positive nor negative. So whenever you have 0, just leave it as 0. And then finally this one had 3 numbers. So we always want to go from left to right when we're doing multiplication. Like if it's all multiplication, we want to go left to right. So I like to do the numbers first, like I said, and then figure out the sign. So 2 times 5 is 10, times 3 is 30, and then we have 2 negatives, which turn into a positive, so we have positive 30. If you wanted to actually do it step by step, you could do 2 times negative 5 is negative 10, and then the negative 3, and then you can see the negative 10 and the negative 3 turn to positive 30. Okay, we are almost done. All we got left is division. And division is really just unmultiplying. You're just undoing a multiplication problem. Multiplying. Right? So you paid $15 for 3 hours tickets. Okay, that's a bit of a typo. You paid $15 for 3 tickets. How much did each ticket cost? So 15 divided by 3 equals 5, right? We already know that from the problem up above. So the notation that we are used to, we have 15 divided by 3, the division symbol. But what we want to start getting used to is just the fraction, 15 over 3. That's the same thing. Or on a calculator, you could do 15/3, right? If you're, let me see if I could pull it up. No, this calculator's dead. Or if you're typing it on a computer, like if you're in Desmos, you can use the slash key, which is by the question mark, right? So on a, this is just a note if you need it. On a computer, it's the question mark slash, right? So that's how you would type it. Okay, so we are dividing 15 divided by 3. This is easier if you can do your times tables. Otherwise, this is hard to do in your head. So hopefully you know your times tables. 15 divided by 3 is 5. Negative 24 divided by 4. Again, so we have 1 negative, 1 positive, so it's negative 6, right? So 24 divided by 4 is 6, and then we have the negative. And then try to do the rest of these, and then we'll check back. All right, you see lots of good stuff? So 12 divided by 3 is 4, but we have 1 negative. 20 divided by 4 is 5, and we have 2 negatives, so they cancel out. It's positive 5. 28 divided by 7 is 4, and we have 1 negative. 9 divided by 1. Remember, anything divided by 1 is itself. A lot of you got that. Okay, this is the trickiest one. 9 over 0. Anything over 0 is called undefined. It's like not allowed. So, anything over 0 is undefined. So this is a math word that you might see in lessons here and there, but pretty much no, you're not allowed to divide by 0, right? If I had a pizza and I was like, I'm dividing by 0, like that doesn't make sense, right? Because dividing by 1 is like, I get the whole pizza. Dividing by 5, I'm splitting the pizza with my 5 friends, but divided by 0, like, I don't know what's happening to that pizza. All right, and then this is the trickiest one. So we have to do everything on top. We have to simplify everything on top before we can do the dividing. So since the 2 is by itself, we can just leave that there. And then we have to multiply this. So 4 times 3 is 12, but then we have the negative. And then once we've done that, now we can divide. So looks like the rest of the problems. 12 divided by 2 is 6. And then we have 1 negative. Very good. All right, so that is it. Hopefully a little bit of a review, but if you just practice, you will get much faster at this.